Hello students, in this lecture we are going to cover the topic that is to derive the relation between E vector and H vector in a uniform plane waves. That is to prove the magnitude of the ratio of E vector and H vector, it is equals to 120 pi ohms or equals to 377 ohms. In the proof, let us consider a uniform plane wave traveling in the z direction, for which the electric field vector is considering along the y direction and magnetic field vector is considering along the x direction. Therefore, for the electric field components, Ex is equals to 0 and Ez is equals to 0 because our electric field vector we are considering here travels along the y direction. Therefore, x and z components are 0. Now the y direction electric field component is given by this equation, that is Ey is equals to E naught cos of omega t minus beta z. Here E naught is the amplitude of the wave along the y direction and beta is the phase constant. Now according to the Maxwell's third equation, that is del cross E is equals to minus curly B by curly t. By expanding this equation or expanding the vectors E and expanding the vector B, it can be written as minus curly by curly t of bx ax plus by ay plus bz az. Here ax, ay and az are the unit vectors. Similarly, this del cross E can be expanded as by using the determinant formula, that is ax, ay, az, curly by curly x, curly by curly y, curly by curly z. This row represents your del, and Ex, Ey, Ez are the vector representation of the complete E vector. Here Ax, Ay, Az are again the unit vectors. Now putting here Ex and Ez equals to 0, as we are assuming here that our electric field vector is traveling along the y direction. So now solving this determinant, after solving we get here the minus ax curly ey by curly z plus az curly ey by curly x. Now equating both sides, and we get this. First of all, we put here the value of Ey, that is in the upper we are assuming here that Ey is equals to E naught cos of omega t minus beta z. So put down this value of Ey here, that is minus ax curly by curly z of E naught cos of omega t minus beta z and plus az curly by curly x of E naught cos of omega t minus bz. And upon solving here, let us, in the second term there is no x component, because E naught cos of omega t minus beta z, it is only varies with the z components. Therefore the differentiation with respect to the x component, it gives you the 0 value. Hence the answer we get here, the minus ax beta E naught cos is converted into the sine, that is sine omega t minus beta z plus 0, because the second term has no x component. Now equating both sides, here is the I vector, that is ax unit vector, and here the also ax unit vector, we are representing it as my curly bx by curly t. It is equals to beta E naught sine of omega t minus beta z. The negative signs are cancelled out with each other, and curly by by curly t is equals to 0 and curly bz by curly t is again equals to 0. Now the components of magnetic field are found by integrating equation this 6a with respect to the time. Integrating both sides this equation with respect to the time, and it gives you bx is equals to minus beta E naught cos of omega t minus beta z divided by omega. Upon integrating, this sign is converted into the cos and the whole term is divided by the omega, or bs is equals to minus beta by omega, and this E naught cos of omega t minus beta z is written as Ey, because in the starting we given representing the Ey as equals to E naught cos of omega t minus beta z. Now also, as phase constant is equals to 2 pi by lambda, this is a relation, and omega is equals to 2 pi mu, and substituting these values of phase shift constant and omega into the equation number 7, we get Bx is equals to minus 2 pi by lambda into 2 pi mu dot Ey. Here the 2 pi cancel out with each other and we left with this minus 1 divided by mu lambda Ey, and it again represented as Bx is equals to minus 1 mu naught. Together this mu and lambda can be written as mu naught. Therefore, our Ey is equals to minus mu naught Bx. Also Bx is equals to mu naught Hx. We know the relation, that is B is equals to mu H, and for the x component it can be written as Bx is equals to mu naught Hx, and mu naught is equals to 1 by square root of mu naught epsilon naught, that is the speed of the light. And substituting these equations in the equation number 8, we get Ey is equals to minus mu naught is 1 by mu naught epsilon naught, and Bx comes out to be mu naught Hx, and upon solving this we get Ey by Hx is equals to minus square root of mu naught by epsilon naught. So in the next term we are changing the directions. Initially we assumed that our electric field is traveling along the y direction and magnetic field along the x direction, but here in this equation we are changing the direction just to absolute this negative sign, and here Ex upon Hy is equals to mu naught by epsilon naught. Here the negative sign is discarded. Now taking the magnitude of this E by H vector, or E by H is equals to mu naught by epsilon naught, and putting down the values of mu naught, that is 4 pi into 10 raised to power minus 7, and epsilon naught, that is 1 by 36 pi into 10 raised to power 9, and upon solving this square root we get the value of 120 pi ohms. And or it can also be, if pi is put down as 3.14, you got 377 ohm. So this is the relation between E and H vector, that is E upon H, or the magnitude of E by H is equals to 120 pi ohms. Now why here the unit comes out to be ohm, this can be seen in the next topic, that is next is the intrinsic or characteristic impedance. It can be represented by eta naught. It is the ratio of, the definition for this is, it is the ratio of transverse components of E and H. Transverse means the perpendicular components of E and H. So eta naught can be written as E by H is equals to the ratio of mu naught by epsilon naught. This can be proved here earlier, that E by H is equals to mu naught by epsilon naught square root. So E has the units volt per meter, H has the units of ampere per meter. Therefore eta naught can be represented with the units volt per meter divided by ampere per meter, or volt per ampere, and the final units we got is the ohms. That's why we write here as E by H is equals to 120 pi ohms, or E by H is equals to 377 ohms. Okay, so this is the intrinsic impedance, or also called as the characteristic impedance. Now another very important topic, that is the E and H are perpendicular to each other always. So to prove here that E dot H is equals to 0. Now first expanding this E and H in the vector forms, that is Ex Ax plus Ay Ey plus Az Ez dot Ax Hx plus Ay Hy plus Az Hz. Expanding the E and H vectors, it's a dot multiplication here, so it can be written as Ex Hx plus Ey Hy plus Ez Hz. And as we in the starting assume that our E vector travels or for the uniform plane waves, Ez is equals to 0 and Hz is equals to 0, as our uniform plane wave travels in the z direction. Therefore here the z components comes out to be 0. And also in the last topic we have covered that Ex by Hy is equals to the square root of mu naught by epsilon naught, and Ey by Hx is equals to the negative square root of mu naught by epsilon naught. So putting these values in the equation number 9, we got E dot H vector is equals to mu naught by epsilon naught Hy minus mu naught by epsilon naught Hx Hy, and both these terms are cancel out each other and we got 0. And what's the meaning of dot product equals to 0? That means both these vectors E and H are perpendicular to each other. Now as the dot product of two vectors is 0 only when the two vectors are perpendicular to each other. Hence E is perpendicular to H vector. Hence proved. So this is the end of this lecture, and in this lecture we have covered the very important topics. That is, the first is the relation between E and H, that is the ratio of E by H is equals to 120 pi, or it is equals to 377 ohm. We have also covered the definition for the intrinsic impedance and characteristic impedance, and the units comes out for this is ohms. And thirdly we have covered here that the E and H vectors are perpendicular to each other as the dot product is equals to 0. Thank you.
Dot products is equal